Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to demonstrate how to find the number of terms in an arithmetic sequence. So I've got three examples listed out and I'll just take them one at a time. Let's start with this one right here, the sequence that says starts at 7, 10, 13. Now you see this dot dot dot. Normally that would mean it's an infinite sequence. However, you see that there's a number at the end of this. So that's basically means this thing's finite because we've got a last value. There's just kind of a bunch of them in between. Okay, so to find the number of terms in the sequence, we could do this a couple of ways. One method would be by brute force. Brute force would be we could just list them all out until we get to 55, count up how many there are, and then we would know how many terms are in the sequence. But what I'm going to do is we're going to do this by writing a formula for the a sub n. And then what we'll do is we'll set the last one equal to 55, and then we'll see what value of n comes out of it. So it's an arithmetic sequence because to get from here to here we're adding 3, and from here to here we're adding 3, and then adding 3, and so forth. So my a sub n here is going to equal 7 plus 3 to the n if we started at n equals 0, but keeping consistent with the current text that I'm using here, we'll start at n equals 1. Which means we need a minus 1 there. See, notice that if I put n equals 1 now, this becomes a 0 and we start at 7. So this is true starting at n equals 1. All right, and what we're going to do now is use this formula here to figure out n, placing the 55 at the last term. So we're going to have 55 equals 7 plus 3 to the n minus 1. And n is now the unknown that I'm trying to find. Let's maybe subtract 7. So let's see, I think that's going to be 48 equals 3 times n minus 1. Subtracting 7 from 55. Dividing by 3, 16 is equal to n minus 1. Adding 1, so 17 is equal to n. Now, the nice thing about starting at n equals 1, right, this is the first one, second one, third one, all the way to the 17th one. So there is 17 terms in this sequence. Had we started at n equals 0, what would have happened is we would have got a 16 out of this, right, but we would have had to add 1 for the n equals 0 term. Still would have ended up concluding 17 terms. All right. Same type of problem. Let's look at this one. And again, first you have to recognize arithmetic sequence. See how to get from here to here we're adding 2, and from 3 to 5 we're adding 2, and so forth. And I'm going to do it the same way. This is a pretty short one. We actually could write it out, but I'm going to go ahead and do it the same method as last time. I'm going to write out a formula. The a sub n is equal to, starting at 1, plus the difference is 2 times n minus 1. And again, this is the correct formula, starting at n equals 1. The last term of the sequence is 15. Then we'll subtract 1. Divide both sides by 2. And then add 1 to both sides. 8 terms in that sequence. All right, take a look at this one. Same method. Now again, you need to recognize that it's an arithmetic sequence here. In future videos we're going to be adding sequence types, but from 2 to negative 2, that's adding 4. From negative, adding negative 4. From negative 2 to negative 6, that's adding negative 4, and so forth. All right, so our a sub n. Okay, you always start with your starting value plus the difference times the n minus 1. Again, this is true starting at n equals 1. This value here is going to be negative 66 on the last term. Subtract 2. Be very careful with minus signs. When you subtract 2 from both sides, this minus sign still stays put. We're going to, the next step is to divide both sides by negative 4. So a minus 68 over minus 4 is a positive value. Looks like, all right, that comes out to be 17 is equal to n minus 1. And then we'll solve for n by adding 1 to both sides. So n is equal to 18. So there is 18 terms in this sequence. So the purpose of this video was how to figure out how many terms there are in an arithmetic sequence. I hope that this helps demonstrate that for you. Have a great day.